Okay, ladies and gentlemen, we were working on lesson 2.3 before we left. We didn't quite finish it, so what I'd like to do is we'll start at the beginning. We'll do all of 2.3 and then we'll do 2.4. We'll give you some homework to do and we'll see you in a couple of days. Okay, let's see what we got here. Factoring quadratic expressions. Factoring is the opposite operation of expanding. You're taking something that is expanded and putting it in terms of its factors. This should have been the word putting. So you're putting it in the terms of its factors. Factoring is the numbers you multiply together to get another number. That's what a factor is. So a factor is something that multiplies with another factor to give you a product. So product and sum is a factoring strategy that you may recall from last year. So we have a trinomial here. We talked before we left that all trinomials are going to break up into two binomials. They're actually going to be structured like this. They're going to have an x at the front of each one because x times x is going to give me the x squared. And then we need to find the two numbers that go in beside them. Well, the product and sum is a factoring strategy. So what we do is we're looking for two numbers that will sum to give us 7, and they're going to have a product of 12. Now, this 12 can be 1 and 12, so I'm making a factor tree. It could be 2 and 6, it could be 3 and 4, and then it's 4 and 3. You see how these doubled over, so it's done. So 3 and 4, 4 and 3, those are the same two factors. So if this trinomial factors, it will be one of these three pairs, and whichever one it is has to go together to sum to give 7. And 3 and 4 are the ones that will sum to give 7. We can have positive 3 and positive 4 will give us 7. So the answer is positive 3 and positive 4. Now, there is no difference if you write it like this. This is still x plus 3 being multiplied by x plus 4. Order of multiplication does not matter. We could see that if we were just looking at two numbers, like maybe 5 times 6 is 30 and 6 times 5 is 30. There is no difference in the order that we multiply them. Now this is what's called factor. This is one of the factors, so this would be a factor. And this is also a factor. So each binomial is a factor of the trinomial. If we were to expand this, we could see that we are in fact right. So if I wanted to check it, well, that's a horrible color. That's not going to do. Let's see if this pen will work. Let's do a check. So to a check, what we do is we expand. So we take the x plus 3 and we take the x plus 4 and we're going to expand it. So x times x is x squared. X times 4 is 4x. 3 times x is 3x. 3 times 4 is 12. Put those together, we get x squared. 4x and 3x are like terms, 7x plus 12. Is that what we started with? It most certainly is. So we are correct that this trinomial, x squared plus 7x plus 12, is equal to these two factors. And what that means is if I was to write out x squared plus 7x plus 12, it is equal to those two factors, just the same way as 15 would be equal to 3 times 5. So what we have here are factors. What we have over here is the product. So this is a trinomial. We have a product of 3 times 5, which is 15. And again, you've been working on that for a while now. You should be experts at it. So we'll look at the next one. We'll put a y at the front, put a y at the front. That gives us y times y is y squared. We're looking for two numbers that will multiply. So a product of 15 and a sum of negative 8. I always start with the products. So 1 and 15. 2 does not go evenly. 3 and 5, they will go together to give me a negative 8 as long as it's a negative 3 and a negative 8. Put those two together. Negative 3 plus negative 5 is negative 8. So negative 3, negative 5, and that's it. Let's check it. Let's do it in our head this time. Y times y is y squared. I'm going to have negative 5y's and negative 3y's, which is negative 8y. Negative 3 times negative 5 is positive 15. It is correct. Next one. Now, this one. Always, always, always try to common factor first. Let's remember what common factoring is. It's where we try to find a factor that goes into each term. You'll notice that this is 2p squared minus 2p minus 40. There is a common multiple of 2. If I take a 2, and if I divide 2p squared by 2, I get left with 2p, or sorry, p squared. And if I take 2p and divide it by 2, I'm left with a 2. And if I take 40 and divide it by 2, I'm left with 2. Try going reverse to see if it's right. This will be 2 times p squared is 2p squared. Negative 2p, negative 40. So this was common factor first, if possible. So we did. Now what we're going to do is we're going to factor the trinomial. Well, the trinomial is going to factor. It's going to get a p at the front of both of them because it's p squared. And now I need two numbers that are a product of 20 or negative 20, depending how you want to think about it. And it's a sum of negative 1. There's an invisible negative 1 there. Well, the product is 1 and 20. That won't work. 2 and 10. That won't work. 3 doesn't go evenly. 4 and 5. 4 and 5 will work as long as it's negative 5 and positive 4. When I add those together, I get negative 1. So I need to move my page up a little bit here. So it's going to be negative 5 in one of them and positive 4 in the other one. And what we have is the answer. So if I take this and if I expand all of this out, I should end up right back where I started. Let's do a check. Let's do 2p minus 5, p plus 4. So I'm going to multiply these two together first. I think it's easier. So it'll be p squared plus 4p negative 5p negative 20. What I did was I expanded that out. It's going to be p squared minus p minus 20. We now take the 2 in. You can't see what I'm doing. I'll bring that up a little bit. We'll take the 2 into each of the terms, and it's 2p squared minus 2p minus 40. Is this what we started with? It most certainly is, which means that this is equal to 2p minus 5, p plus 4. And what we have here are 3 factors in this case, not just 2. All 3 multiply to give me 2p squared minus 2p minus 40. Let's flip the page. Seesaw method. We talked about this before you left. Let me remind you about it. The seesaw method is a little bit different, and we have to use it whenever the number in front of the x squared term, whenever that number a is not equal to 1. So if a does not equal 1, and we cannot factor, not just factor, cannot common factor, to make the a equals 1, then we use seesaw method. Okay? So let's look at this one. I've got a 2 in front of here. It's not a 1. And notice I can't divide 11 by 2 evenly. So that's no good. I can't common factor that out. So I need a new method. The new method that we talked about was to put a 2x and a 2x in front. So this 2 goes here and this 2 goes here. The problem is when we multiply that, I'll have too many 2's. So we also divide by 2. Now that's kind of weird, but you just have to remember it. That's the way it's going to work. Now if I go 2x times 2x, I'll get 4x squared. Divided by 2 will take me down to the 2x squared. So now I'm looking for two numbers. That'll give me a product of, now it's not 12, you got to do 2 times 12. So you're looking for a product of 2 times 12, which is going to be 24. And you're looking for a sum. You don't multiply the 11 by 2. The sum stays just 11. So that's a little bit different this time, okay? Things are a little bit different. So I take my 24. 1 and 24 won't do. 2 and 12, that won't do. 3 and 8. 3 and 8 will work if I have plus 3 and plus 8. So I put my plus 3 in one of them, and I put my plus 8 in the other. Now, something interesting happens. See this 2? It's always going to reduce with a multiple of 2 on top. And you got to find it by looking for what will common factor. This is 2x plus 8. I can common factor out a 2 here. So that 2 would have been 2x, 8. So I'm left with that 2 that's come out. So what we have is 2x plus 3 times 2 times x plus 4. Those two 2's will reduce, leaving us with simply 2x plus 3 and x plus 4. Seems a little weird, but it works. Let's check it. If I'm going to do a check, I'm going to take my 2x plus 3 and my x plus 4. That's going to be 2x squared plus 8x plus 3x plus 12. That's going to give me 12x squared. 8x and 3x go together to give me 11x plus 12, which is what we started with. So it's a little bit different, but if we learn the patterns, we'll be fine. Notice the number in front of the x squared is a 6. It's not a 1. And I can't common a 6 out of all of these terms. So this is a seesaw method. You start off with a 6x and a 6x and a 6 on the bottom. That's what you start with. So you're looking for two numbers that will give you a product. Now do you remember? 6 times 5. So it's a product of 30. And it's got to give you a sum of negative 17. Well, 1 and 30, 2 and 15, that'll work. So if I have negative 2 and if I have negative 15, they will add together to give me negative 17. So it's going to be a negative 2 in one of them and a negative 15 in the other. Now remember, we got to get rid of this bottom number. And we look to common factor the top. The first one has a 2 that can come out of 6x and 2. So we're going to take a 2 out, and it's going to leave me with 3x minus 1. This one has a 3 that can come out of 6, and a 3 that can come out of 15. So it's going to be 2x minus 5. We're still looking for a 6 in the top. Well, we've got 2 times 3x minus 1 times 3 times 2x minus 5. This 3 and this 2 can multiply together to give me a 6. 3x minus 1 and a 2x minus 5. So they went together to give me this 6 here. Well, that 6 on top and this 6 on the bottom will reduce, leaving us with a final answer of 3x minus 1, 2x minus 5. Let's do a quick check to see if we're right. 3x times 2x is 6x squared. This will be negative 15x. Negative 2x is negative 17x. Positive 5, it's correct. All right, well, we're doing great here. Let's see this one. Okay, so the 6 is not a 1. I would really like a 1 here because then it would be an easy one to do, but it's not. It's a 6. I can't common factor a 6 out of 15, so I'm going to use the seesaw method. I put a 6x all over a 6. I need two numbers that are going to multiply to give 6 times negative 9. So 6 times negative 9 is 54. So I need a product of negative 54. And I need a sum of negative 15. So remember, the product gets these two multiplied together. The sum is just the negative 15. Well, 1 and 54 won't work. I'm going to grab my calculator now. 54 divided by 2 is 27. That won't work. 54 divided by 3 is 18. That'll work. As long as it is negative 18 and positive 3, they will sum to give me negative 15. So I'll put my negative 18 there. I'll put my positive 3 there. Looking at these two for common factoring, because remember we have to get rid of the 3 on the bottom. A 6 will come out of both 6x and 18. And a 3 will come out of 6 and 3. I'm going to put brackets around it just so that it looks better to me. This 6 and this 6 will reduce out. That 3 didn't reduce out, so we have to keep it. And if we want it to look good, we put it out in front. And so what we have are 3 factors. 3 factors that all go together to equal 6x squared minus 15x minus 9. So if I multiply all these 3 together, I should end up back with what we started with. Let's take a look if we do. So it's 3, x minus 3, 2x plus 1. So this is what we had. So I'm going to multiply them. I'm going to start by multiplying these two together first. So the 3 comes down. It'll be 2x squared plus x minus 6x minus 3. 3, 2x squared, x take away 6x is minus 5x minus 3. Take the 3 into all 3 terms. 6x squared minus 15x minus 9. Is that what we started with? 6x squared minus 15x minus 9. It is. So what that means, ladies and gentlemen, is if it's expanded, it'll look like that. And if it's factored, it'll look like that. So these 3 things multiply to give that. All right, so let's flip and see what's going on now. So this is the last example. So all of that was stuff that we did before the break. We didn't get to this example, so let's take a look at it. Example 3. For the quadratic, x squared minus 2x minus 8, express the function. So this is a quadratic. Remember, that's going to be a parabola when we graph it. I'm looking at this. The a value is positive, so it's going to open up. And we also know that it's going to hit the y-axis at negative 8. This is in standard form. So if I'm going to put it in factored form, we're going to factor this. Now this is an example where the a value is 1. So I need 2 numbers that multiply to give 8 and add to give 2. Well, that's going to be 4 and 2. So it's going to be x. I need them to be a product of negative 8. I need them to be a sum of negative 2. 1 and 8 won't work. 2 and 4 will work as long as it's negative 4 and positive 2. So negative 4 goes in here and positive 2 goes in here. And this is the factored form. Well, find the x-intercepts and check your answer. Well, the x-intercepts are the places where it's going to cross the x-axis. And if it's going to cross the x-axis, then the y value must be 0. So if the y value is 0, we're going to set f of x equals to 0, and you're going to have x minus 4, x plus 2 equals 0. So the question is, when will this equal 0? Well, this will equal 0 when either x equals positive 4, in which case this will be 0 and this will be 6, but 0 times 6 is 0, or when this x is negative 2, in which case this will be negative 6, but this will be 0. So the nice way to say that is what you do is you say that we're going to get zeros either when x minus 4 equals 0 or x plus 2 equals 0, x equals 4, and x equals negative 2. So your x-intercepts are going to be 4, 0 and negative 2, 0. Find the coordinates of the vertex and the axis of symmetry. Well, if we remember, the axis of symmetry is going to be halfway between these two. So the x value, axis of symmetry, is going to be given by, it's going to be given by 4 subtract, now hold on, I need to think for a minute. I've got to figure out whether it's plus or minus. I think it's 4 plus minus 2 over 2, which is going to be 2 over 2, which is 1. So the axis of symmetry is going to be at x equals 1, halfway between these two. Let's make sure that it really is halfway between, I haven't made a mistake. 4, 0 is here, negative 2, 0 is here. So if I move over 1, and then if I move over 1, yep, I'm right, we worked that out. So that's the axis of symmetry. The coordinates of the vertex, well, the axis of symmetry, if we remember, is going to run right in between the two x-intercepts. So that's x equals 1. We know that our vertex is going to lie on this line, so we can sub in x equals 1 into f of x. Now it doesn't matter whether or not I use the original f of x or if I use the factored f of x. If I plug in x equals 1 into this one, what we'll get is 1 squared minus 2 times 1 minus 8. So that's 1 minus 2, which is negative 1, minus 8 is negative 9. And if I plug in 1 here, I get 1 minus 4. And I get 1 plus 3, or 1 plus 2, sorry. So 1 minus 4 is negative 3. 1 plus 2 is 3. So that also is negative 9. So that means that our vertex is going to be right here at 1, negative 9. We also know from the standard form that it's going to cross the y-axis at negative 8. So at 0, negative 8, we know that it opens up, and we know that it's symmetric, so there's going to be another point here to mirror this point here, and it's going to look like that. So there you go. We have 2.3 done. I'm going to stop here and then we'll do a video for 2.4.